For most of human history, Earth felt stable, predictable, a planet that changed slowly over thousands or even millions of years. But according to NASA, that era is over. Using decades of satellite data, climate models, and deep space monitoring systems, scientists have reached a sobering conclusion. Earth has entered a new phase, one humanity has never experienced before. This warning does not come from speculation. It comes from numbers, from instruments orbiting hundreds of kilometers above the planet, silently recording every change. And those changes are accelerating. NASA's climate satellites have been observing Earth continuously since the late 20th century. They track temperature, ice mass, atmospheric composition, ocean heat, and sea level rise. What they're seeing now is not just change, but momentum. Glaciers in Greenland and Antarctica are melting faster than the most pessimistic models predicted only a decade ago. Some ice sheets have crossed irreversible thresholds, meaning even if warming stopped today, the melting would continue. Sea levels are rising not just steadily, but unevenly, creating new flood zones, reshaping coastlines, and threatening millions of people worldwide. This is no longer a distant future scenario. NASA scientists describe the planet as entering a climate acceleration phase, a period where warming triggers feedback loops that amplify themselves. Melting ice exposes darker surfaces. Darker surfaces absorb more heat. More heat causes more melting. And once these loops begin, they are extremely difficult to stop. But Earth's challenges do not come only from within. Above our atmosphere, another force is growing more active: the sun. NASA has observed a steady increase in solar activity as the sun approaches the peak of its 11-year solar cycle. Solar flares and coronal mass ejections, massive eruptions of charged particles, are becoming more frequent and more intense. Most of the time, Earth's magnetic field protects us, but history shows what happens when a powerful solar storm strikes directly. In 1859, a solar event known as the Carrington event caused telegraph systems to fail across the globe. Today, a similar storm would be far more devastating. Satellites could be disabled, GPS systems could fail, power grids could collapse for weeks or longer. NASA classifies this as a low probability but high impact event. The danger is not certainty, it's vulnerability. Modern civilization depends on fragile systems suspended in space and electricity flowing without interruption. And space does not negotiate. Then there is the threat that feels the most cinematic, yet remains very real: asteroids. NASA currently tracks more than 30,000 near-Earth objects, asteroids whose orbits bring them close to our planet. Most pose no immediate danger, but history reminds us that Earth has been struck before. 66 million years ago, an asteroid impact reshaped the planet and ended the age of the dinosaurs. NASA's calculations show that while large impacts are rare, they are not impossible, and it only takes one object traveling faster than a rifle bullet could darken skies, disrupt global climate, and collapse ecosystems.
Systems nominal. We are
This
go
is
for
why
orbital
NASA
insertion.
created the Planetary Defense Coordination Office, and why missions like DART were launched to test humanity's ability to alter an asteroid's path. It's not science fiction, it's preparation. What makes this moment unique is not any single threat. It's convergence, climate stress, solar instability, cosmic risk, all overlapping in the same historical window. NASA scientists describe this as a dangerous phase, Not because disaster is guaranteed, but because multiple systems are being pushed toward their limits simultaneously. Earth is resilient. It has survived mass extinctions, ice ages, and cosmic impacts. But human civilization has existed for only a fraction of that history. And it evolved during one of the most stable climate periods the planet has ever known. That stability is fading. NASA is not issuing this warning out of fear. It is issuing it out of responsibility. Across the globe, engineers and scientists are working to monitor every variable they can. New climate satellites are being launched to track heat, carbon, and water cycles in unprecedented detail. Solar observatories watch the sun constantly, measuring eruptions before they reach Earth. Asteroid tracking systems scan the sky every night. Knowledge is our advantage. But knowledge alone does not stop consequences. It only buys time. Time to adapt infrastructure. Time to protect critical systems. Time to understand that Earth is not static and never was. NASA's warning is not that the planet is doomed. It's that the margin for error is shrinking. Earth will continue to change. The sun will continue to erupt. Space will remain indifferent. The difference now is that we can finally see it coming. The question is no longer whether Earth's future will be different. It already is. The real question is whether humanity will be ready to face it.
If you're interested in the future of space, be sure to subscribe to Orbital X. Just click the button below for more content every week.